So before you go ahead and get started on the problems that you'll find on Google Classroom, I want to go through this example. I'm going to walk through it step by step. The solution method for this is going to be one of the more complicated ones, but all of the steps, the equations, the concepts are used the same throughout all of the problems. So for this one, what we want to do is figure out the initial velocity at which something is launched at. In this case, we want to figure out how fast is she jumping to make this jump. Now, for this problem, we don't have a lot to go off of other than the image. So what we're going to do is make some assumptions via just a quick little bit of research and then go through our solution process. So what I'm going to do is pull up a chart over here that shows the average height and weight of Olympic athletes based on the event. And this is taken from the 2016 Rio Olympics. So what I have up is the long jump, and you'll notice that there is differences for male and female jumpers. So you notice that most of the female jumpers fall in this area here. So just a quick look at the data, I would say that her average probably falls somewhere in around this bunch, right around this height of 170 centimeters, maybe a little less. Let's just keep it 170 just to give us a nice number to work with. So let's go ahead and move that over again. So we're going to say that average height is going to be 170 centimeters, converted to meters, 1.7 meters. So we want to go ahead and draw in the path of our jump. Looking for theta, we may need that eventually. We also should probably know stuff like what is the height at which she jumps, the total delta y, that could be useful. How far may be useful as well. And some of the other things we know are like time. That's always a useful value for us to know. So let's go ahead and create our chart now of our x and y values that we generally use. Okay. So there's a chart filled in with what we were given. The only thing we know for sure is the acceleration due to gravity of the A. But we're saying that the average height of this athlete is about 1.7 meters. So we can ballpark this overall height. So if we were to look at the overall height of the jump, we could say it's a little over half of her height because she has her legs currently like in a compressed state. So let's go ahead and estimate our delta y. So let's say delta y equals a little bit more than half. So 0.85 would be half. Let's go ahead and make this an even one. That's about a meter up that she jumped. So we can plug that value in for our delta y. So now we know that the height that she jumped. Why don't we go ahead and try and estimate the distance, because that would also be some useful information. Now for total height, if she were standing upright, it would be about 1.7 meters from the ground to the top of her head. So rotating that down, you'd have about another 1.7 meters there. Maybe another 1.7 slightly past the halfway point. 1.7 again, and just under. So let's go with a total of 6.3 meters as a total jump. So now we can go ahead and plug that value into our chart as well. Now with what we're given now, based off these two measurements and that one assumption, we can figure out how fast she jumped. What we start off with is figuring out how fast she had to jump to get a height of 1 meter. So to do that, Let's figure out what VIY is. If we know the height that she jumped, we can use this equation to figure out the velocity at which she jumped at. We know at the peak of a jump, you're going to hit 0 meters per second in the vertical direction. That's because on your way up, you're traveling in a positive direction, positive velocity. On the way back down, you're coming down at a negative velocity. So at the very peak, you have to make that transition from positive to negative. So 0. So go ahead and solve this through for VIY. So what we do, we end up getting a 4.43 meters per second as our VIY. Now since this person is jumping and landing at the same height at which they started from, we can say that VFY is going to be the same. Just going to be a negative value because they're coming back down. Now from there, we can figure out how much time this jump took. And we can figure out that out by using the equation here. Now we plug in our 4.43 as our initial y velocity, how fast you jumped up, and the VFY of negative 4.43 as the velocity at which it was coming back down, and then solve for t. End up getting 0.90 seconds as our total time she is in the air. Which is rather reasonable because as far as my knowledge goes, the maximum time a person can do something like this, land and or jump and land on their feet, is approximately a second. So we're on the high end of that. Now the next bit, we need to figure out Vx. And the reason we need to figure out what Vx is because if you remember, your total velocity is a component thing. You have your V total, you've got your Vx, and you have your Vy. Right now we have the initial vertical velocity that she jumped at. We need to know what her Vx velocity that she's traveling at is in order to figure out the total that she jumped at. Now we're going to figure out this Vx by using the delta x equals Vxt equation. We know what delta x is, the 6.3. And we know our time, so we just have to solve for Vx. Which ends up being 7 meters per second. The last bit now is, what is that V total? And since we have the size to that initial velocity thing now, that initial velocity triangle, we can use the Pythagorean theorem to get V total. So we end up getting 8.28 meters per second as our V total. And that answers our question, with what speed or how fast did she jump off at in order to do that jump? So from here, this is the process you're going to use if you're trying to figure out like the total velocity of something. You need to know values of distance or height or the angle of launch. We didn't find the angle of launch here, but if you wanted to, you can. Go ahead and use that inverse tan function that was introduced recently, where you take the inverse tangent of Vy over Vx. You know those two components, you can figure out the angle that you jumped at. So at this point, go ahead, transition over to those problems in Google Classroom, and when you get those ones done, submit them under the classwork tab. Have a good break.